In this section, we're going to start to look through the iterative solution to the pyramid problem. So let's get started. Now, the first half of this solution is going to look very similar to the steps one. So we want to make a for loop that's going to iterate over each row of our output. So very similar to what we did before, we'll write a for loop and iterate from row equal to 0, row less than n, row plus plus. So that will take us from row 0 all the way up to n minus 1. For each row that we create, just like before, we'll make an empty string here. Now previously we called this empty string something like steps or something like that. This time around, just because we're working with a pyramid, I'm going to call this string level to represent a level of the pyramid. If you want to go with stair or steps or whatever we use, totally fine. There's no difference. Now inside of here is where the real magic begins. So this is where things start to get a little bit different from our initial steps solution. Inside here, we want to iterate over all the different columns inside of our pyramid. And like we said at the end of the last video, the number of columns is not equal to n like it was before with steps. So this time around, we have to say somehow produce for n equals 2, we need to get 3 columns. For n equals 3, we need 5, and so on. Now, one thing I would really caution you against, really try not to look at the relation between each of these levels here. Like, we're not trying to really derive a pattern from 3 going to 5, because you could very quickly be thinking, okay, I just need to like add 2 to something every time. And that's not correct. We don't want to think about the difference in rows, or excuse me, the difference in columns each time. What we're really trying to think of is how n is related to the number of columns. So I don't want to compare 3 to 5 and try to figure out some pattern there. I want to look at 2 to 3, 3 to 5, and 4 to 7 and try to figure out some combination or some pattern between each of those pairs of numbers. So the relation between these, there's not a super easy way to lead into this. I'm just going to tell you what it is. Essentially, the relation is we're going to take n, we're going to double it, and then subtract 1. And that will give us the total number of columns. So we can test this out very quickly in our heads. So 2 times 2 is 4, minus 1 is 3. So that works out. 2 times 3 is 6, minus 1 is 5. So that one's good. And then 2 times 4 minus 1 is 7. So that's pretty much it. We're going to iterate from 0 to 2 times n minus 1. And that will give us the correct number of columns. All right, so back over here, we'll write out our inner for loop. We'll say for let column equal to 0, column less than 2 times n minus 1, column plus plus, like so. Okay, so this will take care of our correct number of columns. Now very quickly, we start to run into the next big issue. So previously when we worked through this problem, when it was all about steps, we had a very clear and easy comparison to make. We had said that if the current column is equal to or less than the current row, we should add a pound. But this time around, it's way different. We've got a much more complicated calculation going here. And really, I'm not sure how much we can just do a very simple comparison between the two to figure out what to do here. In particular, in this case, we have some like range in between here that we need to somehow figure out. So this is another location where some of the math starts to get a little bit hairy. Let's do a quick code up over here and figure out exactly what we need to do. So essentially going from 0, 1, 2, 3, 4, so from values 0, 1, 2, 3, 4, we need to make sure that number 2, or kind of value number 2 in there, gets a pound. So I'm going to kind of do a little pretend over here. Let's say our columns are 0, 1, 2, 3, and 4. And then our row, let's get some identifiers here. Our row at this point is 0. So I need to somehow relate these two sets of numbers together to make sure that I somehow can pull out a pound for this index right here and spaces for these other areas. And then if row was 1, then I would want to make sure, so just to be clear, that would correspond to this second row right here if row is equal to 1. So in that case, I would need to make sure that I can somehow produce a pound here, a pound here, a pound here, but then spaces on the ends. And then of course, for row equals 2, everything needs to be a pound. So we need to figure out some relation to essentially generate that kind of stuff. So here's my thought. I think that what we can do is calculate the midpoint of our array right here. So we'll calculate the midpoint, like what is the very center index of this thing. If we can figure out the center index, then we can say that take row number of elements on either side of that center point and make those into pounds. So with words, that's really confusing. So let's look at what this looks like in practice. So first, I want to get the midpoint of columns right here. To get the midpoint, and when I say midpoint, I'm talking about like the index. So in this case, I would want an index of 2. So I need to somehow turn 0, 1, 2, 3, 4, or 5 into 2. So essentially, let's just get to the point here. Essentially, we can do math.floor 2 times n minus 1, and then divide that by 2, where n is the number of elements, or excuse me, the number of total rows that we're working with. So if we wanted to only consider the actual number of rows here, it would of course be, we're dealing with 5 elements divided by 2. And then we'll take math.floor of that, and that will give us the second element. Just to be clear, that 2 times n minus 1, I kind of made a mistake right there. This is the final solution. I didn't mean to go that far forward. Let's just forget we saw that and just think about 5 divided by 2. So now we can think of 2, and 0 elements on either side should also be made into a pound as well. So only element 2 in this case should be made into a pound. If row goes to 1, then I want to take essentially math.floor and math.floor plus 1 and math.floor minus 1. So elements in position 1, 2, and 3. So 1, 2, and 3 should be made into pounds. So hopefully that makes a little bit of sense here. Again, this is kind of getting into challenging stuff as far as some of these math calculations go. Let's try coding this up, and I think it'll start to make a little bit more sense. So back over here, the first thing we're going to do is to calculate the midpoint of our row. So the midpoint of our row is going to change depending on n, and that's why we had that 2 times n minus 1 calculation in there for a second. So we're going to say the midpoint is at index math.floor 2 times n minus 1 divided by 2, like so. So that's the midpoint index. Now the other thing to keep in mind here is that we are iterating through this list of columns. So in truth, we don't really need to be calculating midpoint every single time here. We could actually calculate midpoint at the very top of our function, because it's only ever going to be reliant upon n, and n is never going to change. So let's pull midpoint out to the very top up here. And then inside of our for loop, all we really have to worry about is watching for row number of elements to the left of midpoint and row number of elements to the right of midpoint as well. So in code, that would look a little something like this. We'll say if midpoint less minus I is less than or equal to, not I, my mistake, row. If midpoint minus row is less than or equal to column, and if midpoint plus row is greater than or equal to column, then we want to add a pound. So this if statement right here is going to make sure that the current column that we are looking at is within the bounds of midpoint minus row and midpoint plus row. So this is a check right here to make sure that we are inside of some bracket of numbers. So if we meet that condition, we'll add in a pound. Otherwise, we'll add in a space, like so. All right, I know that was nasty, but we did get through it. I am pretty confident that if you look at these numbers a little bit, they will make sense. So do, if it still seems a little bit confusing, do try writing it out on paper, for all that matters. And I think that you're going to get a hang of it pretty quickly. So here's our for loop. Inside of there, we assemble 1 row's worth of numbers or 1 level's worth of numbers. So after that for loop, just like before, we will console log out level. So let's see how we're doing with our tests. And back over here, it looks like we've got 4 tests passing. Whew. All right, that was a challenging one, but I think that steps gave us some pretty good preparation, at least to pull it into kind of 2 separate problems that we had to worry about. So this looks good. Let's now continue in the next section.